everyone, in this video we're going to explore topic 8.5 error between curves with respect to y. Alright, so here's the formula. The error equals the integral form y1 to y2, the right curve subtract the left curve dy. Alright, so basically you need to calculate the error of each horizontal rectangles and you're going to add them up, right? In this situation, it should be with respect to y, right? So the variable should be y, right? Now, example number 1. Find the error of the regions bounded by the graphs s equals 3 minus y squared and s equals y plus 1. Alright, keep in mind the right hand side right here always y, right? The left hand side is s, right? So the first thing you need to do is to get the regions, right? So y equals 0, s equals 3. It's going to be right here, right? Y equals 1, s equals 2. It's going to be right here. Y equals -1, s equals 2. So it could be right here, right? Now the graph should be something like this. Now go ahead, get the second one. S equals y plus 1. Y equals 0. S equals 1. It's going to be right here. Y equals 1. S equals 2. It's going to be right here. Now if you connect this one, it should be something like this. Alright, so you need to calculate the error of these shaded regions right here. Now, first you need to find the intersection between two graphs right here. Alright, so you just equate the right hand side, right? Because they both equals s, right? So you have 3 minus y squared equals y plus 1, right? Now convert this one to quadratic equation. So it's going to be y squared plus y minus 2 equals 0. Factor this one is going to be y plus 2 times y minus 1 equals 0. Alright, this one is the zero product, so it should be y plus 2 equals 0 and y minus 1 equals 0, right? So this guy turns out to be y equals -2, y equals 1, right? So the error becomes the integral form -2 to 1, right? This one right here, y equals -2, and this one right here, y equals 1, right? Now, right curve subtract left curve, right curve, which means the right one right here. So it could be 3 minus y squared subtract y plus 1, right? And then this one should be dy, right? So this guy turns out to be the integral form -2 to 1. Simplify this one, is going to be negative y squared minus y, right? This should be -1 right here, plus 2 dy, right? Now take antiderivative of this one, so it's going to be -1/3 y cubed minus 1/2 y squared plus 2y, evaluated from -2 to 1. Alright, substitute 1 over here, so it's going to be -1/3 minus 1/2 plus 2. Subtract. Substitute -2 over here, it's going to be y cubed, it's going to be -8 times -1 right here, it's going to be positive, right? So it should be 8 over 3. -2 squared, it could be 4, so it could be subtract 2 and minus 4, right? Because -2 times 2. Now, if you simplify this one, the answer must be 9 over 2. Alright. Now, let's take a look at example number 2. Find the error bounded by the curves s equals y squared minus 2. y equals -1, y equals 1, and s equals e to the y. Alright, so this one is e to the y, and this one is y squared minus 2, right? Now, we need to shade the regions that is bounded by those given equations. Alright, so it should be this guy right here, right? Because you have y equals -1 right here, and y equals 1 is going to be right here, right? So the error is the integral from -1 to 1, right? Look, from here to here. Right, subtract left, right is this one right here. So it could be e to the y subtract left, which is this one right here, y squared minus 2 dy. Be careful, you need to put the parentheses right here. So it's going to be the integral from -1 to 1 e to the y distribute -1 is going to be negative y squared plus 2 dy, right? Now take antiderivative of this one with respect to y. So it could be e to the y minus 1/3 y cubed plus 2y, right? Evaluated from -1 to 1. Alright, substitute 1 is going to be e minus 1/3 plus 2, right? Substitute -1 for y, so it could be e to the -1 minus 1/3 times -1 cubed, right? Plus 2 times -1. Now we're going to simplify this one. It's going to be e 5/3, right? Now this one right here is going to be 1 over e. So you distribute -1, it's going to be -1 over e. This guy right here becomes 1/3, right? And distribute -1 is going to be -1/3. This guy becomes -2. Distribute -1 is going to be plus 2, right? So it's going to be e minus 1 over e, right? Now 5/3 subtract 1/3 is going to be 4/3, right? 4/3 plus 2 is going to be 10/3, right? This one is the final answer, right? Now, example number 3. Redo example number 1 with respect to s, which means we're going to use the vertical representative rectangles, right? We look at the example number 1 right here. S equals 3 minus y squared. Alright, so s equals 3 minus y squared. You need to write y in terms of s, right? So it's going to be y squared equals -s plus 3, right? Then you're going to take square root both sides, right? So it's going to be y equals plus and minus square root of 3 minus s, right? Now, the second equation is going to be s equals y plus 1. Then you need to rewrite y in terms of s. So y equals s minus 1, right? You just let this guy and this guy equals, so that you're gonna find the intersection, right? Which is I did in the first example, right? So I have y equals -2 and y equals 1, right? So y equals -2, you just substitute -2 for y into this equation right here to solve for s. So s equals -1, right? Similarly, y equals 1, s equals 2, right? That's why you have 2 points right here, right? Now, the error is now from left to right. It's going to be from -1 to 2. You see that the linear function right here is above this guy right here. This guy right here is y equals negative square root of 3 minus s. right? So it's going to be the integral from -1 to 2 of the upper one, which is this guy right here, s minus 1, subtract the lower one right here, which is this guy, negative, so it turns out to be plus, right? 3 minus s ds. Now plus the integral from 2 to 3 right here. How do we know this one 3? We need to find the intersection between this guy and the x-axis. The x-axis, which means y equals 0, right? So basically, you just equate this guy and this guy, right? The system of equation y equals square root of 3 minus s and y equals 0. Then I just equate this guy and this guy. So I have square root of 3 minus s equals 0. Square both sides. 3 minus s equals 0. S equals 3, right? That's why I have 3 right here. So it's going to be the integral from 2 to 3, right? Remember this guy right here. Alright, now the integral from 2 to 3, and you observe that this guy and this guy symmetric, right? Only calculate the error of upper half right here and you multiply by 2, right? In order to calculate the error of upper half right here, does that mean you're going to take the upper function subtract the lower function? The upper function is this guy, the lower function is y equals 0, which is the x-axis, right? So I have square root of 3 minus s, subtract 0, I don't need to write it, right? ds. Then I'm going to multiply by 2, so I'm going to put 2 in the front, right? I'm going to separate this one into 2 integrals, right? So it's going to be the integral from -1 to 2 of s minus 1 ds plus the integral from -1 to 2 square root of 3 minus s ds, right? And this guy right here plus 2 times the integral from 2 to 3 of square root of 3 minus s ds, right? Now it's very simple to calculate the integral of this one, right? Now for this guy right here, I'm going to use substitution, right? So I'm going to call this one I1, I call this one I2, I call this one I3. I need to calculate each of this one and I'm going to add them up, right? Alright, now I'm going to calculate I1. So I1 is the integral from -1 to 2 of s minus 1 ds. Alright, take entire derivative of this one is going to be s squared over 2 minus s, evaluated from -1 to 2, right? And this guy turns out to be, substitute 2 for s, so it's going to be 2 minus 2, right? And substitute -1 for s, it's going to be subtract 1/2 plus 1, right? So it's going to be -3/2. Alright, now I2, you're going to use substitution. So basically, you're going to let u equals the square root side right here. 3 minus s, right? Then you're going to square both sides. So you have u squared equals 3 minus s, right? Then you're going to take the derivative both sides. So it could be 2u du equals -ds, right? Now I'm going to multiply both sides by -1. So I have -2u du equals ds, right? Now I need to change the bounds. Upper bound is s equals 2, lower bound s equals -1. Then u becomes, substitute 2 for s into this guy right here. So you have u equals 1. Substitute -1 for s, u equals 2, right? Now I2 becomes the integral from 2 to 1, right? This guy right here actually u. ds right here actually this guy right here, right? So I have -2u squared du, right? Now I need to flip about and I'm going to change the sign right here, so it becomes positive, right? Integral from 1 to 2 u squared du, right? Now take anti-derivative of this one, so it could be 2 over 3 u cubed evaluated from 1 to 2. So it could be 2 over 3 times 2 cubed minus 1 cubed, right? So it could be 8 subtract 1 is going to be 7. 7 times 2 is going to be 14 over 3, right? Now I3 I do exactly the same thing, right? The only thing different right here is the bounds, right? The lower bound s equals 2, the upper bound s equals 3, right? Right here. Then u becomes, substitute 2 for s into this one right here, u becomes 1, right? Substitute 3 for s, u becomes 0, right? So I3 becomes the integral form 1 to 0 negative 2 u squared du, right? So you need to flip the upper bound and lower bound and change the sign. So it's going to be the integral from 0 to 1 of 2 u squared du. And then it's going to be 2 over 3 u cubed evaluated from 0 to 1. Alright, so it could be 2 over 3 times 1 minus 0. It's going to be 2 over 3. Now, for I3, you need to be careful. You must multiply by 2 right here. Alright, so this guy becomes 4 over 3, right? So you have the error equals I1 equals negative 3 over 2, I2 equals 14 over 3, and I3 equals 4 over 3, right? So it could be negative 3 over 2 plus 18 over 3, right? Now cross multiply, so it could be negative 9 plus 36 over 6, right? So it could be 27 over 6. Divide the top and bottom by 3, so it could be 9 over 2. This one is the final answer. So this one matches the first example right here. Alright. Now let's move on to example number 4. Vertical and horizontal representative rectangles. Find the area of the regions enclosed by the curves y equals 1 over s. Right? The red one right here is y equals 1 over s. Right? Y equals s is this one right here. And y equals 1 for s is copied right here. Alright, so the first thing you need to do is to find the intersection points, right? So in order to find this intersection right here, I need to equate this guy right here and this guy right here, right? So I have y equals 1 over s and y equals s, right? I just equate this guy, so this guy turns out to be s equals 1 over s, right? And then multiply both sides by s, so it's gonna be s squared equals 1. Then s equals plus and minus 1. When you look at this graph right here, you only need s equals 1, right? It's gonna be on the right of the y-axis, right? And then substitute over here, so y equals 1, right? So you have the first order pair, it's gonna be 1 and 1, it's gonna be right here. Now secondly, you're gonna find the intersection right here, which is between this guy and this guy, right? So you have y equals 1 over 4 times s and y equals 1 over s, right? So it could be 1 over 4 times s equals 1 over s, right? Now cross multiply, so it's gonna be s squared equals 4, then s equals plus and minus 2, right? So we only take s equals 2 because it's on the right of the y-axis, right? Then substitute 2 for s into this guy right here. So y equals 1/2, right? That's why you have the point 2, 1/2 is right here, right? Now question A. we need to calculate the error of this guy with respect to s right here, right? So we're gonna go from left to right, right? Left right here, right here. So we're gonna split this one into two errors. The first one is A1 right here. The second one is A2 right here, right? For A1, the upper one should be y equals s. The lower one should be y equals 1 over 4s, right? For A2 right here, the upper one should be the red one right here, y equals 1 over s. The lower one should be y equals 1 over 4s, right? So you have the integral from s equals 0 and s equals 1 right here. 0 to 1. Upper subtract lower. The upper one is y equals s. The lower one is this guy, right? Plus the integral from 1 to 2, right? Right here. The upper one is 1 over s. The lower one is 1 for s, right? Alright, now take antiderivative of each of this one, so it's gonna be 1/2 s squared minus 1 over 8 s squared, right? Evaluated from 0 to 1 plus antiderivative of 1 over s could be natural log of absolute value of s minus 1 over 8 s squared evaluated from 1 to 2, right? So you're going to simplify this one. It becomes, substitute 1 for s, it could be 1 over 2 minus 1 over 8. Substitute 0 for s, it could be 0, right? So I don't need to write. Plus, substitute 2 for s, it could be natural log of absolute value of 2 minus, substitute 2 for s over here and simplify it could be minus 1/2, right? Subtract, substitute 1 for s, it could be natural log of 1. Substitute 1 for s, it could be negative 1 over 8, right? Now I'm going to simplify this one, it could be 1 over 2 minus 1 over 8 plus natural log of 2. I don't need the absolute value side because this one is positive, right? Minus 1 over 2. Natural log of 1 equals 0, right? And this guy, distribute negative 1 over here, it's going to be 1 over 8, right? This guy cancel out. This guy cancel out. The answer is natural log of 2, right? Now for question B, we're going to use y as the variable of integration, right? So we need to go from bottom to top, right? Now the first intersection is right here. The second intersection is right here. And the third one right here, right? So I'm going to project this one to the y-axis, right? So the y values right here should be 1/2, right? And the y values right here should be 1, right? So I have the integral from 0 to 1/2, right? Now right subtract left, right? So the right one right here and the left one is right here, right? The error of this region right here. Alright, now I need to rewrite this one in terms of y, right? So I'm going to multiply both sides by 4, so s equals 4y, right? So I have 4y right here. Subtract y, right? dy plus the integral from 1/2 to 1, right? Now the regions is this guy right here, right? So right subtract left, right is right here and left is right here, right? We write this one in terms of y, right? So s equals 1 over y, right? So I have 1 over y subtract y dy, right? Alright, now I'm going to check antiderivative of this guy. So antiderivative of 4y is going to be 4 over 2 y squared is going to be 2y squared. And this guy becomes negative 1 over 2 y squared, right? Evaluated from 0 to 1/2 plus antiderivative of 1 over y is going to be natural of absolute value of y minus 1 over 2 y squared. Evaluated from 1/2 to 1, right? Alright, so I'm going to simplify this one. Substitute 1/2 over here is going to be 1 over 4, right? So simplify 2 is going to be 1/2. 1/2 substitute over here is going to be 1 over 4, and 1 over 2 is going to be negative 1 over 8. Substitute 0, everything is 0, right? Now for the second one right here, substitute 1 over here. You have natural log of 1. Substitute 1 over here is going to be negative 1 over 2. Subtract, substitute 1/2 is going to be natural log of absolute value of 1 over 2. Substitute 1/2 for y is going to be 1 over 4. And then it's going to be negative 1 over 8, right? Now I'm going to distribute, so it's going to be 1 over 2 minus 1 over 8. Natural log of 1 equals 0, right? So it's going to be negative 1 over 2 minus natural log of 1 over 2 plus 1 over 8, right? This guy cancel out, this guy cancel out. It's going to be negative natural log of 1 over 2. Alright, so it's going to be negative of natural log of 1 subtract natural log of 2, right? So it's going to be negative natural log of 1 plus natural log of 2. Natural log of 1 equals 0, so the final answer should be natural log of 2, which is exactly same thing as question 8 right here, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.